Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present about our case study project is training attendance system. Before we start, I would like to introduce my team members. Firstly is Aina Zahira, secondly is Amira Ardini, thirdly is Muhammad Harun, fourth is Muhammad Amirul Mukmin, next is Ahmad Ifan Nabihan, and lastly me, Nurkuratul Anijana. This project required us to explain about our system, documentation, and Java program code. Firstly, as you can see in this slide, there are participant class and linked list class. Figure 1 shows that the participant class is a representation of a training system participant. The participant name is kept in the name variable. The participant linked list is represented by the linked list class. The initial node in the list is kept track of by the variable head. The node class has two variables. First is participant, which hold the object. Second is variable.
Okay, next. Based on figure 2, register participant is a method which registers a new participant in the system. It creates an object which is the participant's name and creates a new node with the object. If the list is empty, which means the head is null, the new node will become the head in the list. Otherwise, if the list is not empty, the loop iterates until it reaches the last node in the list. Once the last node is found, it sets the next reference of the last node to the newly created node, which means adding the new participant to the end of the list. The figure above shows how the method works and how the new node is added to the list. The register participant method creates a new node with the provided participant's name and adds it to the linked list of participants. If the list is empty, the new node becomes the head. If the list is not empty, the new node is appended to the end of the list by updating the next reference of the last node. This process allows participants to be registered and added to the training attendance system.
Figure 3 shows the method sort participant, which will sort the participants in ascending order based on their names. We will be using the bubble sort algorithm to sort the names in our system. This sorting algorithm begins with checking if the list is empty or only has one participant. If the list is empty or has one participant, no sorting is needed and the program will return, which means we will be using the OR operator in our system. This method performs a nested loop to compare each participant's name lexicographically. If the current participant's name is greater than the next name, swapping is performed to make sure that the list is in an ascending order. The sorting process will continue until the list is completely sorted. This is how the bubble sort algorithm works. Initially, we will list out the data exists. We will compare the current string with the next string. When the first iteration is finished but the list is not yet sorted, continue with the second iteration until the list is sorted. So the first one is Amira, Harun, Jannah, Aina. The first step is compare Amira and Harun. Since Harun is greater than Amira lexicographically or alphabetically, no swap is needed. Compare Harun and Jannah. Since Jannah is greater than Harun lexicographically, no swap is needed also. And then compare Jannah and Aina. Since Jannah is greater than Aina lexicographically, swap is needed because A, the alphabet A comes before the alphabet J. And then this is the end of the first sorting phase. The second sorting phase, Amira, Harun, Aina and Jannah. Compare Amira and Harun. Since Harun is greater than Amira lexicographically, no swap is needed. Compare Harun and Aina. Since Harun is greater than Aina lexicographically, swap is needed because alphabet A comes before the alphabet H. The next one is compare Harun and Jannah. Since Jannah is greater than Harun lexicographically, no swap is needed. And then this is the end of the second sorting phase. The third sorting phase, Amira, Aina, Harun, Jannah. The first step is compare Amira and Aina. Since Aina is greater than Amira lexicographically, no swap is needed. Compare Aina and Harun. Since Harun is greater than Aina, lexicographically, no swap is needed. Compare Harun and Jannah. Since Jannah is greater than Harun lexicographically, no swap is needed also. And then the end of the third sorting phase comes, and the list is sorted. The bubble sort algorithm works by repeatedly swapping adjacent elements. So it compares the alphabet or the element and the next of it. If they are in the wrong order, gradually moving the larger elements towards the end of the list. This process continues until the list is sorted.
This figure shows the display participant method, which will be called in the main class to display the participant list that has been sorted accidentally. When the list is empty, a message will be printed indicating that there is no participant registered yet. Otherwise, this method will go through the list, starting from the head and print each participant's name in the list. In this figure, we can see the method search participant, which function to search the name of the participant in the list. The system provides a name that will be searched, and the method will start to check if the list is empty or not. If the list is empty, a message is shown indicating no participant is registered in the system. Otherwise, starting from the head, the iteration compare each participant name with the provided name, ignoring the case sensitivity. If a participant with the matching name is found, the found is true and the loop stops. It will finally print a message indicating whether the participant exists or not in the list.
So let's go to figure 6. Figure 6 shows the main class training attendance system, where the main system actually works. Firstly, when the program starts, there will be a list of options to be chosen. Based on the chosen option, for example, option 1, so the program for registering new participants will begin, and this flow works the same to other options as well, until the program exits. All options will function based on the method they called, which is either register participant, sort participant, display participant, or search participant. If invalid option is entered, an error message will be displayed.
So now I will show you how our program works. Firstly, we're gonna run our code. As you can see here, there is the list of the options we have made. So I will enter option 1 to register the new participant. So it will ask for the participant name. For example, I will put my name. Okay, so I will add another more participant. So I will select the same option, which is 1, and add another name. Okay, after I already registered a few names for the participant, I want to display the participant list. So I choose the second option, which is display participant list. So as you can see here, the program will list down all the names that I have listed before this. Okay, so the participant list that you can see here is in an ascending order, from Aina, Amira, Harun, and Jannah, firstly. So I want to search for a participant. So I choose option 3. So I want to search for Amira. And as we know, Amira is already registered in this system. so the search result will show Amira. But if I choose an unknown name, for example, and it will show that there is no result for the participant name, and this system will ask to register the participant. And then if I want to exit the program, I choose the option 4 and the program will exit. That's all from us. Thank you.
In conclusion, the training attendance system described in the documentation utilize a linked list data structure and various algorithms to provide functionality such as participant registration, sorting, displaying, and searching. The system is designed around the participant class, which represent an individual participant, and the linked list class, which manage the linked list of participants. Overall, the system provides a basic framework for managing training attendance using linked list, sorting, and searching algorithm. It can be further enhanced and expanded upon to meet specific requirements and incorporate additional features.